We got like 3 of those suckers for like $50 a piece though. Sorry, I was doing that. It was really nice. I'll just sit on that.
Okay, I think we're about to get started. Can you shut off the lights? Just flip them. Oh no. All right. Welcome everyone to the 7th, it's the 7th, right? 7th Hyperloop workshop?
Today is the 7th Hyperloop, yeah.
Oh man, we're like more than halfway through. Yep. This is also the 2nd lab type workshop we're doing this semester, which is on 3D printing. It's a fun one. So today we'll be able to get to build 3D printers and see them work in action. And there's different types of 3D printers that you can also take a look at. Yep. So, but we're first going to start with the boring stuff. And by boring, I mean important stuff, which is the safety lecture, how this crap actually works, stuff like that. So let's see. I'm going to start off talking about like 3D printing in a nutshell. And I actually have a laser pointer now, which is, thank you, Siobhan. I'm going to use this thing. Yeah, it's a laserless laser pointer. So what is 3D printing? And I put a picture of my quote unquote print farm here. I have a bunch of printers. Last time we talked about CAD, and under a CAD we talked about a subset of CAD, which was 3D modeling. And we talked about FDM, which is basically fusion deposition modeling. So this is basically the printers that allow you to squirt really hot plastic onto beds, and they do it in such an action such that it does it layer by layer and eventually makes you a nice little figurine from one of your favorite action movies or whatever the case might be. So fusion deposition modeling squirts plastic, hardens it into a nice shape. Pretty much it. It's also a form of additive manufacturing. So we talked about additive manufacturing and subtractive manufacturing. Additive manufacturing is when you add material to other material to form a shape. Subtractive is when you take away material. So sculpting would be subtractive, but FDM is additive. So why do we 3D print? Actually, we 3D print because it's easy to make prototype parts. I do a lot of projects. I make a lot of things like the battery vending machine in Banshee, and also some RC cars, and also I 3D print things for like the kits you'll build in like a couple weeks. So it's a really easy way of making prototypes, and you can make a lot of them if you have a lot of printers. However, the downside is you have a long print time compared to other methods. Sometimes, yeah. So if you're seeing it, of course, it's going to be much faster compared to 3D printing it. And if you're doing, the powder 3D printing, that's probably like close to the fastest form of 3D printing you'll ever get, but it's very expensive. Yeah, powder printing.
Powder printing, you're not going to have one of those.
Powder printing is, okay, so when we talk about different forms of like 3D printing, we're essentially kind of just talking about the process of how it's being done, right? So FDM is kind of the one that like, this pop filter. FDM is kind of the one that we're going to be working with today. Mostly just when you think about FDM, just think about really hot like glue gun, just moving around really fast on some kind of like axis system kind of thing, or really slow, depending on what you're trying to do. The next one is obviously like an SLA resin printer, and there's kind of 2 ways to do that. There used to really only be one, but because Texas Instrument is not being dorks anymore, you can actually purchase components that allow you to do something a little bit different. And that basically utilizes a UV curing like resin, and you essentially display the, how should I say, like the actual, yeah. Exactly. It's essentially just a cross section that you're basically just building up or whatever the case may be. And you do that layer by layer by layer. A lot quieter, however, a lot more pain in the butt, right? Almost always. That SLA stuff does not smell good, right? Almost ever. And then the last one is SLS, which is basically just nylon stuff. Really, really, really high quality parts, really, really expensive. Really, really, really hard to attain. And then of course there's also metal printers. There's in between the metal printers. Like I said, guys, there's a ton of nuance to this stuff. And for the sake of today, for as much as he might get excited about this, we're gonna kind of stick to 3-dimensional. We're not gonna deal with any weird 4th-dimensional 5-axis systems. We're not gonna deal with any of that, because to be honest with you, there is no really well-known commercial or open source method for doing something like that, unless you're some kind of cave goblin who just likes to figure that stuff out for whatever reason. Yeah. So we're going to just stick to the 3-axis systems. And then FDM on top of that. If you guys want to talk about SLA, we can. I can basically really remove you from the idea of ever buying one. So, all right.
Oh, you have to talk about this.
Oh, yeah.
So something I do is like, you can also do mass production with 3D printers, and it's sometimes like, actually it's a lot cheaper than actually, putting it in a mold and casting it, however, yeah, sometimes. Well, I guess there are exceptions, but if you're a consumer electronics hobbyist and you're just doing this as a hobby, do not go into casting or anything. It's probably just a better choice.
Unless you want to figure it out. Right?
Yeah, unless you want to do it. But it takes time, takes money. Yeah. Recently, there has been a really large development in consumer electronics, especially for 3D printing. Like 10 years ago, these were like really expensive. Like Sam's printer right here, 10K easily. So we've come a long way in the form of consumer electronics. And I think most recently, the AnkerMake M3 is pulling out its first consumer electronics printing for like $1,000, basically targeted towards people who aren't into 3D printing. So basically like your normal printer at home, think of that, but like 3D printer. One push of a button, it prints something. It's very, very, very simple.
It's the first, Bamboo, I think, is the first actual like decent attempt at that. I mean, like there have been systems in the past that tried to do that, but they weren't, I mean,
So that's not good.
Yeah, the beginning of 3D printers really came from, I think the RepRap community.
Yeah, you had companies like, and these were just guys, right? Originally when this whole thing was really kind of starting to hit the community deal, it's always kind of been a community deal. They didn't, at least for me, when it was introduced to me, you had two main kind of big players in the deal, and it was MakerBot, and then also there was a couple other smaller ones, but Printer. And Printer and MakerBot were pretty much the two guys that everybody had ever heard of. I met the founders of both, right? Like at the time when that was sort of getting started, you could go to Maker Faire and meet them. They were there. I mean, in all of their bask and glory, right? I mean, so believe it or not, the community itself has still kind of retained that same sort of behavior. It's just gotten a lot bigger, right? Because now you have different kinds of designers, like the main Voron designer who basically made this system, and then you have a bunch of people who created mods or modifications to these, and then essentially that would either be merged with the main project, or it would be something that would just be like an aftermarket kind of thing. You can make it, whatever the case may be. Or you can go the other route, right? With what we mentioned before, the Bamboos or Perusas or any of that kind of stuff. You basically just buy the kit and you just build it. But with Perusas, it's a little bit different because he actually has a pretty massive printer farm. Half the parts you get from Perusa are just the parts he slinged out on his systems. I mean, he's got maybe, oh, no worries. He's got maybe 500 of those machines just running constantly, right? Printing, Petchi, pretty much the whole time.
They're printers printing printers.
Yeah. Yeah, it's kind of ironic, right? I mean, considering when you look at my system, I mean, 50% of it is printed parts. So, I mean, and it came off of my buddy's printer, right? That it was the same thing for him, right? So it's kind of a trivial, funny thing, but that's, I mean, legitimately how it works, because when you come to these really intricate parts where it costs more to manufacture them for whatever, I mean, it doesn't cost us anything to manufacture these parts. I mean, like, I think I paid that dude, and he included an extruder for me. I think for all the parts he printed for me, I think it was almost $50. I mean, it's stupid, right? I mean, like, and it didn't cost him that to make that either. It was mostly just print time and him spending the time to kind of get it all set up for me and whatever the case may be. But yeah, no, that's pretty bad.
Yeah. Prusa has about, I think there's a video on his channel where it's like road to 100K printers. It's insane. He makes his own filament. There's a bunch of printers now. You should see the amount of power he uses in that facility. Yeah. He also has a power meter. It's insane.
Had to get an upgraded break box.
Yeah.
I think everyone is divided up into a 240-volt system, and then the other systems are, he's taking a lot of power.
It's just mind-blowing.
He's making money. I mean, he's selling.
True.
Those kits don't cost him more than $150 to make, but he's selling for almost $800. That is very profitable.
Definitely. Okay, let's talk about 3D printing materials. We talked about some of them last time I did, but like it's pretty important to go over just because it's gonna affect your printing experience, your output of your printers, and also some of them are a little bit more dangerous than others, and you kind of have to know that before printing. First one, PLA. Pretty standard. Almost everyone uses it. Not dangerous. Relatively safe. Cornstarch, yes.
Yep.
It's biodegradable too.
Yep. Not easy to recycle either.
Yep. ABS. Oh, this one's the fun one. ABS is really strong. It's really strong,
Good
really
surface
hard.
level adhesion.
Yeah.
Much. Actually, in some cases, you can get better surface adhesion with PLA. But ABS generally just has better tension. So it's going to survive impacts on there.
It is more dangerous than PLA though, so make sure you have good ventilation.
VOCs. Yeah, you don't want to smell them.
Yeah.
You don't want to huff them. That's not good. That's not good. That's bad. There are printers that are designed to print that, and they have filters on them. I can actually mod my printer right now to have that. I just don't. So, because I like the things. It reminds me. So, all right, next. We're all good.
Next, PETG or PETG?
PETG, the demon material. The devil's material. It's what many of my friends call that. I'm not trying to be mean, but it's not. Oh. A PETG is really cool. It's got a high tensile strength, relatively higher melting temperature. It's goopy. It does not like to be cool at all. Okay, so when you're printing PETG and you're using an open printer, turn that cooling all the way down to 0. It does not want it. You are going to get really bad results if you do that. So, and we will talk about settings and all that kind of stuff. It is relatively safe. It does not release VOCs to my knowledge. I kind of hate it, but I got some anyway, so it works.
It's kind of like the combination between PLA and ABS.
Yeah, it's a good in between. Yeah, it's a good in between. Very hard to recycle. In fact, it's almost suggested that when you break that stuff, you just throw it away. Yeah, because it will release VOCs the second time it's recycled. So
dangerous. Want to explain to them what BSO is here?
Which one?
The BSO, what it releases.
Oh, VOCs. Yeah, you guys know what a VOC is? Yeah. You kind of the idea. What was that called?
VOC, volatile organic compounds.
Organic compounds. Yeah. That stuff that reacts with you, and it can be really bad, right? So essentially, you're trying to think of something that's like not illegal that I can kind of tell you that like it's what I'm anticipating. Sure, yeah, carcinogens. Yeah, that's a great one. Yeah, so with carcinogens, with stuff like aerosol and anything like that, so aerosols, that's what they used to use as a gas that they put inside hairsprays and that kind of stuff, because it expands under very ideal characteristics, right? Not like 120 degree Palm Desert weather, but like LA 80 degree weather, it actually expands pretty well, right? However, it is terrible for our atmosphere, right? It rips O3, which is ozone, apart and everything like that. And that's why we had that big hole over Chile, I think, last I heard, but that was years ago. So it's probably moved. But what's up?
VOCs or CFCs?
VOCs.
CFCs are a part, I believe it's like a part of the umbrella term, if I'm not mistaken, but you can correct me if you're wrong. I'm not a chemistry guy, so I don't know. But all I know is VOC bad. Don't ever stuff that stuff. If you smell too much of it, get out of it. Ventilate it. Go outside. Don't breathe it in. It's like breathing paint fumes. It isn't good stuff.
It's an irritant. And like I've experienced it before. It's like you go outside of the printing room and it's like a breath of fresh air. It's like incredible.
Unless you're made of money, pal, you only got one set of lungs.
Yeah.
Try to take care of yourself, and that's one of those things. Please take care of yourself. That's like one of the two things that I need to be careful about is breathing stuff and getting radiated by stuff. That's like two things I do not.
Touching stuff too.
Yeah, touching stuff too. I mean, that's whatever. Just be mindful. PLA and that kind of stuff, which is what we're going to be mostly working on.
So is that only in VOC?
No.
ABS.
ABS. If you reheat PETG, it'll release because there's a different chemical compound breakdown that happens.
If you guys want to start a print farm, I suggest you get two things: a power meter and like an air quality checker. And by the way,
Maybe just a printer first.
a printer first, definitely. Actually, I'm gonna just say this now, but I think we have one extra workshop, a bonus workshop at the very end for air quality sensing that is going to be sponsored by IEEE's NTC committee, which is nanotechnology.
Plug it in there. It's gonna be bad in there.
Yeah, but they are providing you guys with like free sensors and stuff. So if you guys want some, it's on December 2nd.
Yeah. You live in LA. That's actually a kind of a fun place to measure that stuff. Like unironically, I mean, I'm not trying to be mean, but it's like, it's, you know, we actually kind of have an issue here with that. So that's kind of, you know, that's pretty fun.
Yeah.
That's cool. I'll be there. Okay.
Any questions?
Is there any more?
There's a ton more, but like I think I saw some hands. Yeah. Which workshop?
Oh, it hasn't happened yet.
Oh, it hasn't happened. It's
Last,
in December.
yeah.
It's a. Oh no, no, because like it's like kind of like an unofficial official workshop. We're still trying to figure it out, but I'm throwing it out there right now because we're talking about air quality. If you want a free air quality sensor, go to that workshop. TPU. Oh, this one's fun. So TPU is basically rubber. It's flexible filament. If you want to make something that absorbs vibrations or shock, print in TPU. You can also use it to print wheel rims and make it have a lot of grip with the ground compared to PLA. And it's very useful for that kind of thing too.
When we rate, there's an additional metric that is typically included with TPU, and that is its softness. I'm not trying to sound whatever, but yeah, no, it literally is your softness. And believe it or not, the softer the TPU becomes, the more difficult it is to print, because the issue is, and I can show you a picture if you want, the TPU can get so soft that it doesn't follow the correct drivetrain when it's supposed to go into the extruder head like that, right? So it goes somewhere else. I don't like that. Right? In fact, actually, that's a big pain in my butt. And that is one of the reasons why I hate TPU, because TPU is a pain in the butt to print sometimes. Not only that, it's very temperamental. You got to keep TPU within, like, PLA has a temperature range of like what? 185 degrees centigrade to almost like 200, and I've almost pushed that 230, right? I mean, we're talking like almost a 50 to 60 degree difference, and PLA will still be fine. But we talk about TPU, like TPU, if you are off within a degree, almost 2 degrees or something like that, which I'm not saying that's a problem for me, it's just kind of a pain in the butt because you have mixed temperature problems and everything like that. Temperature control, ambient control starts to become an issue, right? I don't like it. Chris likes it. He's got a lot more success than I do with it. Maybe it's because of my enclosures with all my systems, maybe not.
Yeah, let me tell you the story about TPU. So
it's flexible if you just bend it.
True. So the thing about TPU is I have a printer that's specifically for TPU, for printing TPU, because it's so sketchy. It needs very exact settings. You need to tune it a lot. And if you print in TPU, you need two things, basically. A direct drive printer, Bowen 2 will not work because it's flexible. And the second thing is you need to print very slowly. Unless you get a high-speed one of those.
TPU, I'm going to be honest with you. I know people who use that stuff, it doesn't. High-speed TPU is like 100 millimeters per second. That's not fast. Oh, yeah. Okay, I mean, that's not, I mean, you know, because I'm printing maybe 600 on that, right? So it's like, that thing's slinging, and I can't use those settings with that printer at all. So when I watch TPU print, I'm like, oh, I'm like, did you tell me I have to wait for this? Like this is, yeah, it is a snail. There's only one speed you run that printer on, and that's fast. Because that thing is designed to run that. Now on my other printers, maybe, right? But whatever the case may be. So, yeah, a good point.
Nylon. As we go further down the list, it's going to get more painful.
It just becomes more temperamental. Can't keep that stuff out for more than a day. It absorbs moisture really, really hard. In fact, I actually know a guy who prints exclusively in nylon, and he dehumidifies that room to like Saharan dry, 10% moisture. It is dry in there, and everything works just fine. But he can't keep that nylon out in that room for more than like a day. Otherwise, it's ruined. I mean, like that stuff, it is so temperamental in terms of like moisture content. What's up?
Final prints?
No, but in the meantime, the rolls, you can ruin a $50 roll of nylon if you keep it out for more than a day. Yeah, now that's a sad day, especially for somebody who doesn't understand how that works. You can get dry boxes, and that's basically how you accumulate for that. So a dry box is basically just a heated box, keeps the, heat high good, no moisture, right? So like that's always the best thing for that. And for him, the dry box is running directly to the printer. I mean, like it is
there's almost no time for like any air exposure.
It's attached to the printer usually.
Essentially, right? I mean, same with my setup, but I don't use nylon because I enjoy my mental health to the point that, you know, I don't want to have like something like that. But nylon's awesome. It's super lightweight. Really, it can print really well if you get the whole thing tuned in, and it's strong. I mean, they even make like carbon fiber nylon threaded stuff. So if you got a printer that is set up to basically work with abrasive materials, and you do one pass line and everything like that, your entire print could be reinforced with a carbon thread. And that's, I mean, it kind of works, I guess. Like, I mean, there's more things to that than just that, but whatever. So it's good stuff if you can get it to work. If not, don't bother. Okay, so don't ever, you know, unless you're like, oh, Sam, I remember Sam talking about nylon. I really want to use this now. I mean, then, you know, whatever, right? But if not, don't. It's not worth it. Yeah. So.
And about the dry box, you also need to keep the other filaments if you're not using it, like in a dry box. I don't because I'm too cheap for one. And Hatchbox usually is okay in regards to like lifetime outside of dry box.
PLA you can keep.
Yeah, PLA you're fine. Anything else,
ABS and all the rest.
be careful. I remember because we're talking about like brands of filaments. A common theme in this presentation, we got to probably hurry it up a bit, but the common theme is use good filament. Don't use cheap filaments, because if you use cheap filaments, it snaps mid-print. I've done it before, made that mistake. Do not use cheap filament. And if you guys want tips on like which filament to get, Hatchbox, and you can talk to us. But Hatchbox, that's the one I use. And I also get cheap filament from them, and they do like wonders. It's actually pretty good.
I just buy it from the US. US typically, US manufacturers typically just make good plastics.
Yeah.
I mean, I'm not trying to be mean, but it's like, it's just better quality control for that kind of thing.
Yeah, don't buy it from China.
Well, maybe you want to.
Just get
you're gonna
high
have
quality.
Printing, you're gonna be broke, right? So
Yeah.
like, I mean, you might as well go all in or not, right? For whatever the case may be, especially if you want a better experience.
The printer is just the tip of the iceberg. Everything else that comes on top of that is extra. Okay. PVA. Oh, this one's fun. Okay, so for dual extruder printers, PVA is the kind of material that allows you to print supports, and then you can dip the entire print in like water and then have the supports dissolve right off. It's really cool.
Now, as you can imagine, you don't want that stuff exposed to moisture either.
Yeah.
Because that could also destroy the plastic. So like, because it is a moisture dissolving plastic. So keep it out of moisture, right? So I think there's a general theme here at this plastics.
Yeah. I mean, there's a general theme with like all these materials. Make sure you keep things dry. And I mean, like, I work in my print farm. Basically, I have a workstation in there. I probably shouldn't work in there anymore. It gets dry and hot in there, AF. Like, it's crazy.
Sweaty nerd atmosphere.
Basically. That's why I don't use a dry box, because my room is the dry box. Next one's composites. Oh, this is okay. Like, you're probably not going to print with this
That's the
ever.
carbon fiber stuff I was talking about, yeah.
Yeah. School has one though.
Yep.
So.
Yeah, they do.
Okay, we're on section 2. There are 6 sections, by the way. 7 sections, maybe.
We'll swing through this really
Okay, safety, really quick. Make sure printing area is well ventilated, even if it's PLA. Like, you don't want to be smelling that stuff. A lot of people like print in their closets. That's fine because like humidity reasons, but you're not working in the closet, right? So some materials can be toxic in small environments, including ABS. You definitely want ventilation for ABS. Remember, VOCs are terrible. Keep hands away from the nozzle and other tight spaces. Nozzles can heat up to 220 degrees Celsius, which is more than enough to burn flesh. Like, these printers will get up to 220 degrees. There are nozzles that go up to like, yeah. And it's Celsius, not Fahrenheit. So you know how hot it actually is. It's like 800 something degrees Fahrenheit. Enough to burn flesh. Printers have many moving parts. They're stepper motors. They do not care about your hand being in the way and can crush it if you're not careful.
I've crushed my hand.
Yeah.
It hurts.
Yeah. Don't stick your hand in there when it's like moving and stuff. Wear appropriate clothing to keep you safe. So I hope everyone has closed-toed shoes, mainly because the reason is if you drop a heavy thing on it, you won't crush your foot. But if you like,
Or hot plastic.
or you drop hot plastic, yeah. Mm-hmm. Tie your hair back if you have long hair, so it doesn't get caught in stepper motors and moving parts, because that's the last thing you want your hair to be inside.
I think I lectured a few of these guys last time about that.
Yeah. Handle sharp objects with care.
Yeah, no stabbing.
Yep, hand off sharp objects with the handle outwards. We covered this during the first circuit construction workshop. So if you have a sharp object, hand it out with like the handle and not the sharp object. Otherwise, you might trip and stab them.
If you are going to stab something, just make sure your other hand isn't in the way of the path that you're trying to go.
Yeah.
That's something that Adam Savage talked about. There's going to be times you're going to stab stuff. Just make sure there's nothing of you that's on the other side. So.
And watch your fingers. Make sure it's not between blades.
Yeah. Because those things are sharp. You may think it's just some dumb little. They hurt.
Yeah, especially this model. If you get like the really expensive wire cutters, they're like really nice. They cut through like plastic like butter, but like they're super sharp.
Even the cheap ones are super sharp too.
Mhm.
So,
Definitely. And the last thing, do not over tighten screws. Oh, this is an important one. Okay, so for those of you who are building 3D printers today, I know like you are gonna have to screw in screws and you're like, ooh, screws, this goes in and I wanna make sure my printer doesn't fall apart, so I'm gonna screw it in tightly. You're gonna like break something, you're gonna strip screws, you're gonna just, it's terrible. So don't over tighten screws as long as it's in, as long as you like give it like one good turns.
talked about this last week too.
Yeah, so just make sure you don't
Don't do that.
do it. Don't over tighten screws.
If you're worried about it, ask.
Yeah.
Ask us.
Printer calibration. Let's talk about this for a second. For calibrating the bed.
Well, yeah. There's different ways to calibrate stuff. When we talk about working with a printer, it's not like your classic HP printer where the ink costs literally more than the printer, right? In some most cases nowadays. And like, you just kind of throw some paper in and you're like, align, and then everything's all good to go, right? With these kinds of printers, you have to keep in mind that now we're printing in a third axis, meaning that there is a third part of complexity to this device, right? Now there are ways, designed by the same people who designed these, to automate your process to make it a little bit easier, but there are problems with them, right? The first one is that when we talk about bed leveling, we talk about a physical bed. Some beds are stationary, right? So like on my Voron 2.4, that is a stationary bed. I do not adjust a damn thing on that thing. I literally just tell it to go through, probe everything, and you're good to go. We're all set. In other cases though, you have situations like pretty much every printer we have here today that uses bed screws with basically a spring to tension, right? How high or low that bed is relative to the nozzle's zero position, right? Now, there is an art to basically getting this thing right. Because the thing is that if it's too close to the nozzle, it'll clog the nozzle because not enough plastic is flowing through. And it's too away from the nozzle, then it's like a glue gun, right? You know, you're literally just gonna have it oozing, it's not gonna adhere, it's not gonna work. And I'm talking, like for that printer, I'm talking like 0.5 millimeter difference, right? Like that's how literally like this thing is. And I will teach you guys a technique on how to do that for the printers that do not have an auto bed leveling system. Now, for bed probing, that's a little different, right? Because now you have a probe that literally goes around and basically tests to see where the bed lies relative to the nozzle's absolute position that you programmed. So even though you were using a bed leveler, there is at least one time that you did actually level it correctly with that probe on. And you better be damn sure that was correct, because that is literally going to be your indefinite, all correct. This is what the printer thinks. This is how far the probe is. And anytime you remove that probe for maintenance or you do anything like that, you got to redo it. Because I guarantee you guys, you think you're going to rebuild it and it's going to be the exact same. It's not. These tolerances are not correct. We're working with like cheap Chinese metal. It's not going to hold the same tensile retention that we had before.
It's going to degrade over time.
It's going to degrade over time, absolutely. There's different probes out there.
Even if you get like a probe, and by the way, people who are working with Shivam today are going to be doing CR Touch stuff. Make sure you at least level the bed once manually before using the probe,
Please.
because sometimes it's like so off level
yeah.
that the BL toucher is not even
You
going
don't
to
even
work.
have to do the paper technique either. You gotta just eyeball
You
it.
can
Just
eyeball it.
just make sure it's not so far off that you're just gonna scratch something, because then you're gonna destroy a probe and I'm gonna cry.
Yeah, no.
So-
Please don't destroy my probe. It's like $50.
Yeah, that's an expensive probe.
Yeah. So like when you do it manually, by the way, if you work a lot with 3D printers, you get kind of this muscle memory, even with like different printers, of like how far it should be. what about eyeballing, what you do is you get the nozzle very close to the bed so that you kind of just like estimate how much is far from it. You disable the stepper motors and you just move the head around, and you can adjust it on all four corners that way.
Yeah. I mean, you could do that. With mine, what's kind of nice with some of the upper level printers is they have what's called a real-time adjustment. So as you're printing, you can actually tell it to move just a little bit of a step inward or outward to fix it. Yeah, baby step system. That is the greatest feature, hands down, on this printer that I've ever had, and I wish every printer had that. Okay, I mean, like it is ridiculous that not every printer has that, because it is a pain in the butt to restart everything, especially with the stock firmware settings that these printers come with, every single time you have some adherence issue. That is like literally the main reason why most people get so frustrated with this stuff. And that baby step system is like, it's not even like a difficult feature to implement. It is just a realistic feature. So we will talk about that more with that muscle memory and kind of seeing. And if you hear scratching sounds, then there's a problem. So stop. Turn off the printer, right? Like, I don't care if you have a safety stop, literally just go to the back and just shut it off.
Stick a switch.
It's not worth it. Don't let it run through.
Yeah.
Yeah.
All right. E-step calibration. What do I have for this?
My goodness.
Okay. Yeah. Okay. E-step is pretty important, and not many people know about this actually. Basically, E-step stands for extruder step. If basically your extruder motor will extrude out filament, and sometimes it'll go over or go under depending on what you have it set up by default. So you want to calibrate this. Basically, you're going to go ahead and tell the printer, extrude me 100 millimeters, and you're going to take off the Bowen tube and you're going to cut it off. If it extrudes 100 millimeters exactly, you don't have to do anything, but usually it's not. Usually it's like 90 millimeters or something, and it's really bad. So you're going to go ahead and measure that using a caliper, what it extruded out, the actual value, and you're going to plug it into like a calculator online. There's a formula to do it, but yeah, just plug it in. And then you're going to do this 3 times and find the average of like what it tells you to. Yes. You do it 3 times because it's like sometimes different, and you get the best results from it. It's crazy. Hold on, I saw someone in the waiting room. What time is it?
I think it's 6.
Oh, is it 6? Oh God. Wait, where's the waiting room? I saw someone enter the waiting room.
Open up the chat.
Open. Oh, okay. Okay. I'm gonna assume they left. Yeah. How are we on time?
Yeah, we're 5:35.
Okay. So calibration prints. Oh, this is fun. I like talking about this. So when you're printing, you want to make sure your printing is printing stuff right. So there's a bunch of different tests that you can do to make sure it's right. Yeah, so there's the classic 20 millimeter cube. There's a flow cube for flow settings. You have a CaliCat. That's fun.
My favorite.
You have 3D Benchy, which is that boat up there. It's like very famous. Basically,
Although there are better ones out there.
there are better ones out there, yeah. But Benchy tests for overhangs mainly, the slopes, and then like the chimneys. Do you have accurate chimneys?
Benchy's awesome because so many people have so you can cross compare.
Do you know the thing where you can stack 2 benches on top of each other to test the?
I've seen I've only seen somebody do that once successfully.
I've done it once, but like it's difficult.
That bridging stuff is hard. So.
And the last one is the torture toaster. I like this one because it's moving parts. And if your printer can print this and it worked perfectly, you're golden. You're set. Because this is really hard to print. Printer troubleshooting. Okay. There are a ton of different reasons why printers can break. Like, we're just going to cover like the tip of the iceberg, but there's like so many things. First thing is adhesion. Is your plastic sticking to your bed? If it's not, it can be any of these and more. So you can have messy first layer, and if your messy first layer, that's like the top one there, pointed at the this thing. So that's the messy first layer. It means that even though your print started, if you take it off and look at the bottom, it didn't really start. It kind of like scrunched up like that. And for most of these, just check that the nozzle is the correct distance away from the bed. So like Sam said, you had the 0.5 millimeter. It's like, that's how much difference between calibrated well and calibrated not well. So everything else is basically your nozzle distance from the bed. Like elephant's foot, which is this one.
Little number right there.
Yeah, this one up here. Oh, fancy. What's that? I was like, what? You can have warping, which is basically too far. it can be fused to the bed, which is like the worst thing because you ruin your bed like that. It's like if your nozzle's way too close to the bed.
Doing that once.
Yeah. It's too close. And if it's fused to the bed, basically it's a pain to get off, and it's like you basically just gotta throw the bed away.
Destroy the bed too.
Yeah. When you get good at this, you can actually feel it, feel the filament, feel the first layer, and if it feels right, like you internally just know that it's
That completely like evades what we stated before about not putting your hands in the printer like while
like.
And I can't do that with that thing.
No, don't do it with that.
Too fast that I can't do that. I'm just like,
Yeah. So I'm not saying like put your hand in the middle of a print. So like usually for a print, it'll print a line on the side that will basically purge the nozzle of any like impurity. The purge line, yeah. And then when it goes to the middle to print the rest, you just like feel like the side of it, and it feels right. Like if you have a like little bump and it's nicely sticking to the bed, then you know it's printing correctly.
Print lines are kind of also made to have like excess filament to heat up process that's hanging on the nozzle. It's supposed to take care of it. If you don't have a scrub bucket or something like that, which some printers do have, especially this community, they love that stuff. They love the ability. It's basically like a little system that what it does is before every print, what it does is when the nozzle's heated, there's a little wire brush, and it runs the nozzle across the wire brush, and it just starts automatically. Yeah, no, it's ridiculous. I mean, these guys have figured it all out to the point that they just say, and then everything just kind of like goes. But that's almost never the case anyway. So, but I mean, it's neat. It's a neat thought process. So.
Yeah. And then like the last one is material. Like your print material has a great effect on like what you print as well. Just side story. I remember when Alex, who was our vice president last year, gave me a roll of colorful filaments to print, and that ruined my bed because the colorful filament was like really cheap ones from Amazon, and it fused to the bed. I was like, what is going on? Like it was the same exact settings in my previous one, but it just ruined it. Like it was a terrible filament. So just spend a few more dollars, get good filament. Kind of like this. It's actually really nice filament from Hatchbox, and invest in high quality filament. Filament issues. Okay, let's talk about this next. Okay, again, filament issues can be caused by bad filament as well. So this comes back to the theme of get good filaments, right? You can have stringing, which is basically this down here. If you don't have a great retraction value, then you can, when the nozzle travels across one end to another, it'll leave behind a small string of PLA or whatever material you're using.
Generally, if you get a direct drive system, it's less of a problem because you have a much more high, you're controlling the filament much more closely. Also with direct drive, you don't really need to move the plastic nearly as far away from the nozzle anymore because again, you have that good direction control.
It's good stuff.
Yeah. So that's stringing. Pillowing is when you have holes in the top layer. I've never actually personally had this. You've had it? It basically is the result of not enough cooling. If you don't have enough cooling with like wherever your nozzle is located, you're gonna have like holes because it was really soft and it dragged down. And I don't have anything else to say about that.
Pilling also happens from over-extrusion.
Oh, over-extrusion, yeah. If you have too much filament on your print.
If you didn't calibrate your E steps right, then that can sometimes happen. It can happen.
Yeah. You can have over or under extrusion. For this one, you just check your flow rate.
Yep, E steps, flow rate, whatever.
Filament breaks mid-print, get better filament.
Yeah. Just,
that's the solution for that.
That's a dry box issue, almost automatically.
Yep. Okay, I talked about that. And
bad.
Again, just get good filament, and Hatchbox is the one I use. And if you guys want a deal on Hatchbox filament, just let me know. Yep. Print shift. Oh, I love this one.
That's a bad one.
Yeah.
That's real bad.
Yeah.
Dude, they had an earthquake last year. That is terrible.
Your bed is like,
Oh.
Yeah, look at that.
No, that's.
So print shifts rarely happen actually, but when it does, you like know you messed up.
It's probably a belt issue.
It's a hardware issue basically.
It's probably.
So your belt slipped and like the entire thing just got shifted.
Yeah. Remember, you're a hardware issue too. So if you bump into that thing when that thing's running and it misses steps because of that, you disaligned it and you will have a shift.
Yeah.
I have done that.
Like if an earthquake happens in the middle of a print, GG.
I mean, believe it or not, there are some printer systems that actually can overcome that, but it's like
they're on like vibrational like plates.
Yeah, well, and that too, but like also, especially like the flying gantry systems, the F0 or like the Micron. If the belts are really well tuned and everything's all good to go, and you have decent whatever. It actually, you actually can shake the thing quite a bit and it actually won't mess up. I've seen it. Like my buddy, he had his V0 running and he just shook the table that was on it and it was fine. I mean, the print came out just fine. I mean, but I mean, it took, it scared it scared me. I mean, I was real scared when I saw him do that, but no shift. It was good.
Amazing.
Yep.
So better filament, get a better printer too.
Spend more money, get better stuff.
Yeah, so generally it's caused by bad adhesion, a hardware defect like belts are slipping, the lack of oil lubricant, or malfunctioning drive coupler.
Always remember to do this.
Yeah,
People
oil
do
your
not
stuff.
do that, and that is,
Yeah, lube your printer.
yeah, please. Otherwise, you're going to destroy parts.
So, Salmon Skin. Oh, this one's also fun. So if your print is not smooth, it's usually caused by any one of these things. Also, Salmon Skin is the official term for when infill is seen on the outside of a print. And by the way, infill is kind of like the stuff inside of the model. It's not like 100% filled in. It's like there's a pattern on it, and we'll cover that later.
Yep.
Alternatively, you have vibrations or oscillations from outer walls seen on the prints. It's kind of like this first model here. Like it's not smoothly outside where it should be, so something's going on. To fix this issue, you want to remove combing. You want to include a Z-step between each layer. You want to reduce flow and increase retraction. Now, these ones will increase your print time, but it kind of sucks.
Yeah, there are other ways too. It really depends.
Or you can just upgrade your hardware.
Yeah, like that printer, he has an accelerometer in it. So I did accelerometer tuning to figure out like where his vibrations and oscillations actually occur, and it mitigates it.
You can also do PID heat tuning, but that's like a really advanced
Well,
concept.
you need to do that. Anyway, I mean, I did that with mine.
Yeah.
Actually, if you're running Clipper, it does it automatically.
Mhm.
It's really easy. It's just a script that you just run. Yeah. So.
Oh, cool. We're on
Slicer's cool.
Slicer guide. Okay, this is just gonna be a bunch of terminologies that we're gonna have to cover.
Actually,
And
this whole lecture has been
yeah,
so
we're basically throwing to you guys like 3 years of a dictionary of 3D printing. Actually, we have links to dictionaries of 3D printing that covers all of this stuff in detail. Okay, let's go over this. Infill, the percent of internal material in a print. So like this picture here. Yeah, so 12%, 30%, 50%.
That's grid.
It's grid, yeah.
That's grid.
You can have like gyroid. Gyroid's fun.
There's a bunch of different avenues. Whatever. Some are better for others.
Usually you just want to stick with 15% if you want like a loose one. You don't want to go 100% because that takes absolutely forever. Like the higher you go, of course, it's going to take more time.
Depends on what you're trying to do.
Yeah. Support structure, like this tree structure right here, is to account for overhangs. This is an architectural model.
Don't use trees. Don't use tree support. No, that's so bad.
Temp, when you say temp, it can be the nozzle temp or the bed temp. It also changes with the material used for printing. Print speed, by default, it's like 50 to 60 millimeters per second, but you can bump it up to like 150 to 200 millimeters.
Nice.
With better hot enough grid.
What do you want me to be old and gray by the time it comes out? Yeah. This changes depending on what your system's capabilities.
That's just the default.
Yeah, that's that's funny. That's a good one. That's good. That's rich.
Travel speed is the speed of the printer when it's not extruding filaments. So if it has to travel from one point to another, that's what it is. Print orientation, you want to choose this before slicing. It's very important because it determines, the length of the print. If
Also how well it's going to
yeah, so you want to print it on the right side. Wall thickness, it's how many layers of wall you have before the infill begins.
There's also top layer of thickness, bottom layer of thickness.
There's a bunch of things, but we're just covering the surface level. Flow is the rate at which filament exits the nozzle. Retraction is the rate at which filament is retracted back into the nozzle to prevent straining. Combing is when the nozzle drags over already printed parts, which reduces the print quality.
Yeah, I mean, we'll talk about that.
Cooling is hardening filament right after it lands on the model, and it's also very useful for precision prints.
Cooling is very important, depending on your process.
Yeah.
That means a lot.
So they have like giant fans on like the top of the nozzle.
That's why I got really loud ones.
Yeah. Like, because for cooling, you want to make sure that the plastic hardens as soon as possible after leaving the nozzle.
Because Pitchy doesn't like that.
Right,
ABS and
true.
PLA do. Right?
Depending on the material.
Really depends.
Depending on the material.
Really depends.
That's a good point. Bridging is the ability for a printer to print over a large overhang. And by the way, like a Prusa can do this really well.
Nice. That's a nice bridge.
Yeah. This is what you'll usually get.
Yeah, I worked months. Yeah, my bridging will work that much. So that's
It's an art.
it is an art. Yeah, bridging is definitely an art.
Yeah. And then finally, we have spaghetti for when prints fail.
Send me your spaghetti, guys. Tell me. Oh my
He just looked.
Chris, is that yours?
No.
Oh my goodness.
But this poor guy probably left it in the workshop for like the entire
That's
weekend.
$20 a filament right there.
It's like over a kilo.
You guys ever heard of like FOMO? You guys ever heard of that? It's like the fear of missing out. That's like a real thing in 3D printing, right? Because if you leave your printer to just print, and you're so confident that it's gonna do well, that's like the time when it screws up. It's
karma.
Oh yeah. Oh yeah. That first print that you're like, yeah, you know what, dude? I've had like 5 good prints. I'm gonna go like get a sandwich or something and like let this thing print. Come back.
Get that sandwich and it's gone.
Blob something.
Yeah.
Yeah. That's real hard.
It's a good point to also talk about. You want to make sure you like visually, like you stare at the printer for the first few layers, just to make sure the first few layers
Yeah,
are
'cause that's
good.
usually where the issue starts.
Yeah.
So, unless you got like little siblings. Then problems every time.
Yeah. And you know, for like the first layer prints, I also got you guys white filament for PLA, just because white is like kind of the best color that you can
Easy
see.
to see where problems are.
Yeah.
Yep.
Cool. We're finally here. Printer accessories.
Man,
We're gonna talk about a little bit of a
reason I am poor.
you don't need these, but
They're nice.
they're modifications. CR Touch, semi-automatic bed leveling, Octoprint.
Oh, what is that doing there?
Sam doesn't like Octoprint.
Yeah, no.
It's kind of like your intro for
too
remote.
much headroom. It's too. No, it's not lightweight enough. That's
Yeah.
not good.
Remote monitoring of prints through RPi. You can just do this through anything. It doesn't have to be Octoprint.
It could be fluid, main sail. There's a bunch of different ones out there.
Yeah. PEI bed. I like this one, so I put it included in there. It's a magnetic bed that allows for easy removal of prints.
That's what this is. This is
Yeah.
the
PEI is amazing.
Yeah, it's good stuff. It's just basically just a coated material. It's really easy to adhere stuff to it. I still use glue because I'm
It
kind of
wears off after.
because I'm kind of well, I'm also kind of dumb, like in terms of like leveling stuff. So I'm kind of impatient with that stuff sometimes. Which you shouldn't be.
Yeah.
So
NPA. Sam was like, "What the heck is this?" NPA stands for nanopolymer adhesive. It's kind of like the it's glue on steroids. So it's a formula that a US company made in order to allow for easy adhesion. It heats up and sticks really well when it's hot. It smells like alcohol. And when it's cooled down, it rips off really easily. So
cool. That's pretty cool.
it's a very, very nice formula.
Okay.
Yeah.
Metal extrusion.
Metal extruder, it's a stronger, more consistent extrusion. You
Wanna
kind of
do the
want
abrasive
this.
stuff like I was talking about.
Yeah. And then finally, linear rails, less slippage, smoother transitions, more consistent. You love them.
Yeah, there is nothing better than linear rails. Those things are quieter, much faster, much more stable, much easier to work with, much easier to lubricate, much easier in every aspect whatsoever. They are so nice, and you can get linear rails in any size you want, right? So it's really cool, especially if you want to get as deep down the rabbit hole as I have, and you want to actually build your own stuff. Then you can make some really impressive stuff that way. I mean, so they're great. I love linear rails.
Basically just ball bearings,
Ball bearings, yeah.
inside like a rail.
Little tiny balls on each side of the rail right there. It's good stuff.
Beautiful.
Yep.
Okay.
Don't put this stuff on the
No.
rails. Don't
Okay.
smash.
Yeah. I'll send this PowerPoint to you guys. You can access it after. Here are some useful links if you want to do some further research.
I'll give you a lot more too.
Yeah. I'll ask Sam and he can provide you like a. The description of the YouTube video is going to be really long for this one, guys.
Yes, it is. It's gonna be big.
Okay. Wait, was the last one section 6 or was this section 7? I can't count. Okay. This is probably section 7.
Lab activities. Yay!
Okay, so I have pre-assigned you guys to groups based on your interest and what you put in the form. I think Masha has it.
And I'll know. And I will put you back to another group.
All right. So we're from what Masha said, we're going to change up the groups a little bit because we don't have enough people for some, I think, and also Yash is not here. We have 4 printers that we are going to be going over today. The first one's going to be the Ender 3 printer. It's a very good entry-level printer. It's like what you guys should start with, honestly. And you'll be able to fully construct this from scratch, perform calibration, troubleshooting, and fine-tuning techniques for printing. We're going to use white PLA filament to test prints using sliced calibration files that Sam will go over with you later. And you're also going to examine the imperfections of a machine and correct for them either in the hardware or software. There is a lot of imperfections. And yeah. And I'm going. And I think we're also going to go over firmware upgrades. I use Marlin firmware just because the default firmware absolutely sucks. And so I have the link for that.
Default is Marlin,
but it's not good Marlin.
That's a much better.
Yeah, it's an updated version. So if you guys marked none to beginner, actually, if you guys marked no experience with 3D printing, you guys will be building one of these. And it'll be with Sam / and or Shivam, because Yash is not here and he was supposed to be a lead. All right, if you're a little bit experienced with 3D printer but want to skip past all the building part, we also have the Ender 3 Pro, which is the one that Sam just showed. This is when we ask, the printer is now built, so now what? We're going to upgrade the printer with a CR Touch, basically giving it auto leveling features. By default, the printer will go ahead and level itself on the Z-axis using this like little limit switch, but in this case, we're going to automatically level it using the CR Touch. Again, we're going to upgrade the firmware, perform bed leveling with auto level mechanism. Again, make sure you manually level the bed before adjusting using the fine tuning method. And then you're going to optimize the calibration cubes using that sentence doesn't make sense. Calibration cubes. Okay, so now if you put in anywhere from beginner to intermediate on your form, you're going to be building this boy, which is the CR30, which I also called Belty. This is my third one. So this one is a pain to calibrate. It's like an absolute nightmare. And like I once spent 3 weeks just to get my first belt printer correctly calibrated, and the next one took me like 2 days. But it's really hard. Just that's the thing. Really complicated calibration sequence. I actually put the calibration sequence in the presenter notes so you can take a look at it. There's a custom slicer program for it, but I think you also said Super Slicer has. Awesome. I need to look into that. There's also looping G-code from firmware upgrade. That means you can print something for an infinite amount of time as long as you have the filament and power. You can also fix the bed adhesion using isopropyl alcohol and nanopolymer adhesive. I think that's IPA. I have a couple bottles of IPA in there. It's the best thing ever because it cleans, it makes it,
Bed right up.
Yep, definitely. Definitely. We're also going to do E-step calibration using a calibration strip because it's a different thing for a 45-degree printer. And then, yes, it's different. You have to print like this really long rectangle that tells you exactly how long it is. And then you're going to print a calibration cube just to see if it works. Okay, so Mancha, can you come up here and go ahead and announce the groups? And we're going to get into like different corners of the room. We're going to go ahead and go into different corners of the room based on which group you're in. So if you are in group 1, you're going to go to the back left corner of the room where I'm pointing. If you're in group 2, back right corner. And if you're in group 3, come to this corner. How about that? Do it 3 groups or 4? Okay.
Just if you're there with Sam then too.
Okay.
1, 2, 3, 4, 1, 2, 3, 4, yeah.
We're going to go ahead and have 3 groups there?
Yeah.
3 groups.
So Addie, Maria, Chantel, and Ryan, you're with Sam.
What's group number?
Oh, it would be group 2.
Group 2. So group 2 go over there in that corner.
And then Kevin, Johnny, Dennis, and Shree here with Shivam. Should be group 3.
So group 3, head over to this corner.
Down over here. Group 3. This side of the room. Raphael, you're with Sam. So group 2.
And then group 1.
Which is me, Kai, Adeline, Bethany, Borg, Maggie, and Gabriel. You're with Chris.
So go to the back left corner of the room. So for those of you who are watching this recording, I hope you guys enjoyed the safety lecture on 3D printing and hope you guys have a great day. But we are going to go to the lab now. So see you later. Bye-bye.